Okay, so in this video, we're going to go ahead and start using our GCF to go ahead and factor polynomials. This is the first style of factoring that you'll ever come across. It is also always your first step when you go through and do any other style of factoring. You should always be looking for the GCF first. Okay, so it's really important, so we need to make sure that we go ahead and discuss this first. So doing the same idea here, I want to see what 12 and 30 have in common. Okay, so 12, if I want to do a little quick factor tree out to the side, 12 is 6 times 2, and 30 is 6 times 5. So I can see that we have a 6 in common as far as the numbers go. And then I want to look at my x cubed and x squared. Remember, my smallest exponent is the number that I need, so I need an x squared. So my actual GCF is 6x squared. Now what we're going to go ahead and do with this is we're going to go ahead and take it out of each one. And how we're going to do this is using the style of division that we talked about by going ahead and taking each piece of these and divide it by my GCF. And what's going to happen here is my GCF gets written out to the front. We go ahead and use a set of parentheses. And we go ahead and simplify each fraction and write it inside the parentheses. All right, so 12 divided by 6 is 2. And x cubed and x squared, they divide, I'm left with x. Okay, if you're not sure where this is coming from, go back and look at my video on dividing polynomials by monomials. All right, and the plus sign stays. And 30 divided by 6 is 5. And the x squareds completely cancel, so this is what I'm left with. All right, and notice what I have for numbers inside the binomial are what's left over from when I did a quick factor tree. Okay, so if I want to go ahead and check this, and you probably should, all right, is we go ahead back through and just go ahead and distribute. So we go back and do our multiplication just to make sure I end up with back where I started from. So 6 times 2 is 12. X squared times x, remember we add the exponent, so 2 plus 1 is x to the third. So there's my 12x to the third. And then I'm going to go ahead and distribute to the 5. 6 times 5 is 30. And x squared. And I should have a match to what I started off with. All right? Would like you to go ahead and try the problem number 1 that goes with this. Right now, let's look at the next example. All right, and I notice that my numbers all end in 5. This might be not too bad, okay? So 45 is 9 times 5, or 5 times 9. 15 is 5 times 3. And 30 is 5 times 6. We just did 30. So I can see my numbers are all going to have a 5 in common. Notice I didn't bother doing a factor tree this time. Okay? So sometimes if you're really good with your multiplication, you could just go ahead and get it right out. Now, my lowest exponent on my y's is 1. So they're only going to have a y in common. So I'm going to be dividing everything by 5y, which is my GCF. Okay, so I write my 5y out to the front, right? Put a set of parentheses and then go ahead and simplify each fraction. And remember, when I do the division with the numbers, I should end up with these guys right here. So I've already done most of the work. So 45 divided by 5 is 9. y to the 5th minus 1, remember we have to go ahead and subtract, gives me y to the 4th. Minus 15 divided by 5 is 3, and y to the 2 minus 1 is just y, or y to the 1st. Plus 30 divided by 5 is going to be 6, and my y's are going to completely cancel out. I have one on the top and one on the bottom. And I have gone ahead and factored by pulling out of there. Now, I want you to notice something. I kind of did this on purpose. This was not the largest, this was not the greatest common factor, because if you go ahead and look back, you'll see that 9, 3, and 6 all have something else in common. I should have done a factor tree. That's okay. Don't panic. Okay? So if you don't get it all out the first time around, and you happen to notice that they still have something in common, you take care of it after the fact. So you don't have to go and erase everything and redo it. Okay? So my greatest common factor wasn't 5y because I still have a 3 I could take out. So what we're going to go ahead and do is, rather than redo this whole problem all over again, I'm going to say, okay, I need to pull out another 3, which means I need to go ahead and divide all these by 3, which means I need to take this 5 and multiply it by 3 to get my GCF. So now my GCF is actually 15y. And once I divide everything by 3, I have 3 y to the 4th. These 3's cancel, leaving me with just the y. And 6 divided by 3 is 2. Now I can see that everything is as simple as possible. What I'm trying to get, I'm not trying to confuse you. What I'm trying to let you know is if you don't get it the first time around, because you got all excited because it was so easy to get, that's okay. Take another step here and take out the remainder. Okay, so 45 and 30 are both divisible by 15. If you saw that first and you're laughing at me, that's totally okay too. But let's remember that we don't always see the GCF right away. We see what we see and we pull it out. That's okay. You can always do that. You just might take an extra step to get there, and this is totally okay. All right, we're going to look at a few other ones, okay? I won't try to trick you. We're actually going to go ahead and try to find the GCF right away, all right? But remember, if you don't, and you're working these on your own, just go back and take out some more. It's totally all right. Let's go ahead and look at this example. Now, I like to do letters first, okay? And I can see that I have exponents 1 on my C and my D. So I know my GCF is going to have a C and a D. Now, I have pretty small numbers here. I have a 3, a 30, and a 12. 3 is prime, so as long as 3 divides into both 30 and 12, I'm okay. In this case, it does. I can't go any bigger than 3 because I only have a 3 here, okay? So I'm going to divide all of these by 3CD. All right, I'm going to go ahead, I'm going to go ahead and just move this guy down just a little bit. All right, I'm going to go ahead and do my division. So I have 4CD squared, because I have 2 of them, 3 minus 1, minus 10 C squared D, and then minus. Now, all of these cancel, right? So remember, when everything cancels, it's actually 1. Remember, 3 divided by 3 is 1. So there's a 1 here. Because remember, you need that 1. Because when you go back and check this by distribution, you need to come back with 3 terms. Without that 1 there, you won't get the minus 3 CD part. Okay? So remember, this 1 is really important. You got to make sure that you have it. So if everything simplifies, make sure that there's a 1 there. You need to have the same number of terms as you started off with. All right? Now sometimes you have to pull out a negative number. All right? And so we're going to look at what happens when we go ahead and pull out a negative number. Now my GCF in this case is going to be 5. We can see 5, 10, and 15. It's going to be a 5. My lowest exponent on my A's is 2. My lowest exponent on my B's is this 1 here. But in general, when your first term is negative, we want to pull out a negative. And we'll get more practice with that as we go. But I'm telling you, we're going to pull out a negative. All right. What happens is now we got to divide all this by negative 5a squared b. All right, and again, I'm going to move this down. It's just kind of high. All right, and then I'm going to do the division. Now, a negative divided by a negative is a positive. The b's are going to cancel, and I am left with a to the 4 minus 2, or a squared. So I usually, when it's negative, make sure you do your signs first. Again, a negative and a negative is a positive. 10 divided by 5 is 2. I have 1a left over and 1b left over. Now, last piece, a negative and a positive, give me a minus or a negative. My a squareds are going to cancel, and I'm left with 2 b's. So I have a 3 from the 15 divided by 5 and 2 b's. All right. Now, what should happen when you pull out a negative is all your signs should be the exact opposite of what they were. All right. So originally the first term was negative, it is now positive. The second term was negative, it is now positive. And the third term was positive, and now it is negative. All right, so make sure that when you're pulling out a negative, double check your signs. That's the number 1 error when we go ahead and do it this way. All right, the last example looks a little odd, but this time we're going to go ahead and pull out a binomial GCF. Okay, and what we're looking at with a binomial GCF is we're looking to make sure that the outside term is being multiplied by whatever's in parentheses, and whatever's in parentheses is exactly the same. So in this case, my b plus 2 is exactly the same, and my b plus 2 is my GCF. Because it is a binomial, I'm going to go ahead and put it in parentheses, because when I pull stuff out, it's going to get multiplied. And I'm going to divide each of these by b plus 2. All right. And what happens is because there's multiplication, I can cancel the same numerator with the same denominator. In this case, because the b plus 2 is exactly the same and in a set of parentheses, they are going to cancel each other out. That leaves me with just the a squared. The addition sign is going to stay, and the same thing is going to happen with the other one, and it should. The b's plus 2's are going to cancel, leaving you with just the 5. Now this one, in order to check it, we actually have to go ahead and FOIL. And we should go ahead and do that. So I'm going to go ahead, I have b times a squared, okay, which is a squared b. I like to put them in alphabetical order. You don't have to. I have b and a positive 5, so plus 5b, plus 2a squared, plus 10. Okay, and notice this one is a 4-term polynomial that I cannot do anything with. That is because this is part of what we call factoring by grouping. And it's one of the steps in factoring by grouping, which will be our next topic. Okay, so right now you just pulled out a binomial GCF, but it is one of the steps in factoring by grouping, which is the next style of factoring we are going to go ahead and talk about after GCFs. So have a great day. I will see you in the next video. Make sure you work on the practice problems.